G'day. Today I'm working on my Darex drill sharpener. Normally this lives in a spot behind the door because I don't use it enough that I need to have it front and centre, but today it's out here because I need to do some modifications to the drill grinding fixture. I want to make a step drill. Now there are two things that are called a step drill. One is this sort of thing, which is used by sheet metal workers. Not that one. The step drill I'm going for is something like this. This is way bigger, but it's the same sort of thing. There's a step in the drill so it'll do two diameters at once. Now I'll explain why that's important to me a little bit later on. One of the nice things about the M5 is it'll do all sorts of fancy sorts of drills if you have the right attachment. Unfortunately, these things haven't been made for probably close on 20 years. When I contacted Darex, who make it, they don't have drawings and pictures and things available for people, and so it's a matter of, from their instructions, trying to work out how the attachment operates and how I can get that effect. From the instructions, the way that you grind a step drill, and this is a W point which I did a while back, but I'm going to convert it to a step drill, is, and this is all loose by the way because I've been playing with it, but you basically start off like that and feed it in. Now the problem is that when this is adjusted right over, it hits here and it's not quite at 180 degrees. So what that means is that when I grind that drill, it's not going to be a parallel sort of step. It's going to have some back angle on it. And I don't want that for reasons, once again, I'll explain in a moment. What I need to do is make up a new one of these, or rather a new foot plate here. This is zinc die cast, and you can tell it's zinc because it's got this sort of dull grey finish to it. Aluminium doesn't go that way, zinc does. Zinc will start out very shiny, but soon oxidises down to this. And so I can't just cut a bit off and weld a bit on. That won't work. What I've got to do is basically fabricate a new one. This is the reason I want a step drill. It's a socket head cap screw and it goes into some of this. This is the aluminium extrusion which you see around the place. It goes under a variety of brand names. I think there's an Australian brand called AME, there's a US brand called 8020, there's some German and French brands. But it's all basically the same sort of thing. It's an aluminium extrusion with a T-slot there, and you put a nut in there and you can bolt things to it. But what I want to do is bolt this to another piece down here, and so I need to put in a clearance hole for a 6mm screw plus a countersink for the head. And this is where it gets tricky, because if I were to do this normally I'd have to clamp this rigidly to a milling machine, drill my 6mm clearance hole, and then drill my, it's a little bit over 10mm, but the clearance hole for the head. Because this is to be an interrupted cut, it's got to be clamped rigidly, and I might be able to use my flat bottom drills, but then again I might not. Whereas if I have a pilot, a drill with a step drill with a pilot on it, I can drill in here, and then using the pilot to steady it, I can then do this bit. Now I mentioned earlier I didn't want a back taper on it, and the reason for that is that if I have too much taper here, it means this is going to wobble around in the hole and it's going to be a bit awkward here, and with the interrupted cut I'm not sure I like that idea. So although a little bit of taper might be desirable for clearance purposes, I don't want to have too much. So that's basically why I'm looking at a step drill for this. It means that I can come along in one hit and do this, so it saves me a bit of time, but it means that the counter bore, for want of a better term here, is aligned with the screw hole. One mod, or perhaps restoration, that I'd like to mention before I get onto the drill fixture proper is this. Originally these came with a National Fine 3/8 thread, 24 TPI, with a matching wing nut, and the idea would be you'd put that on there and the wing nut would do up and everything would be wonderful. Now I think what's happened over its life is the wing nut's been lost, and rather than trying to find a National Fine wing nut here in Australia, which is difficult, someone has come along and they've put in basically a bit of an M10 by 1.5 stud. Now there's two things wrong with this. One is that that gap there is only 10 wide, and so that's why they've ground the sides out. But the other thing is that with that finer pitch thread, you get better locking, better torque on the thing. So I've made up a stud which is M10 down here because they tapped that M10 and I can't make it smaller. But the top I've made 3/8 NF again and made up a little knob for it. And so that'll go on like so, and then down there, and that locks up quite nicely. And what that means is instead of having to reach for a spanner because there was a hex nut on there before, I can now change my point angle much more easily with that. This is the base piece, and this is actually from a spare I've got. I've been given a few bits of broken up machines by people, and I like having spares because, you know, it's a nice machine. Now, the problem I've got is that if I try to get 180 degrees, I run into that. I was originally thinking of stopping it about there somewhere, but that only get me to 118 degrees, and if I was trying to do a step drill that would countersink a hole for a bolt in one go, I really want to get that to 90, so I've got to get up there somewhere. However, what I've also realised is that if I take this block, which everything bolts onto, and I push that over about 10 degrees, that will mean that when this is, you know, on 180 true, this will only read 170. Now, because I'm making up a new base, I can put a new arrow on there, and that's not a problem. I can't really modify this one because this is, as I say, in die cast, and I don't think the result I'd get would be something that I'd be happy with. So what I'm going to do is make up a new base piece, and then I think I'll be welding a piece of aluminium flat on there to kicked off at that angle to give me that equivalent. Now this is an interesting shape because the centre of these radii, and that's a guide radii too, is up here somewhere. So I'm going to have a blank with a point here for the centre so I can find that. But there are a couple of ways of getting that profile. One of them is, as I've done here, is to basically just draw around it with a pencil. I've then used some basic geometry to work out where the centre of these radii all are, and that one is, and this one, they all meet up here somewhere. So that's basically the centre of my radii. Now, underneath here, there's a little bit of relief. There's a thing here, and there's another one there. So to get that, what I've got is I've got some bearing glue here. This is just a tube of stuff I have. You can make your own, but what I'm going to do is I'm just going to do that to transfer some glue on, which, as you can see, isn't all that successful. Now, I just tried rubbing that on my piece of glass with the bearing glue on it, and I didn't get very good take up because casting is not as flat as it could be. I did try transferring that onto here. That didn't work because, once again, against the glass is flat. So what I've done is I've got a bit of rag here, and just ignore that. That was a trial piece. What I'll do is, finding a clear spot here, is push that down there on the rag, and I'm hoping that the rag will take up the lack of flatness. Well, there you go. So that's my shape. That's my profile there that I need to put onto the back of my machining. So I think what I'll end up doing is I'll probably have to do this slot and this slot in the same setting, just for my own peace of mind. This is just normal, rectangular type stuff, and then I can come along and I can do this front edge and the angled piece here at my leisure, flip it over, because this doesn't have to be precisely lined up with this one. I wasn't 100% happy with my sketched outlines and trying to dimension off them, so I'm being a little bit more scientific here. Well, it took a little bit of mucking around because I had to adjust the position of the pointer here on the dial indicator with respect to the axis of the mill, and then adjust the x-axis to get the pointer in contact. I also had to adjust the wire a little bit. I had thought that there was a maximum here that would be a centre line, but it's not. It's only 0.8 of a millimetre out, but it's not quite right. And so I've now got this so that will, when I rotate that, I get about a thou of movement over the sweep, which is good enough. So now that I know where that centre is, I can re-zero, I can work out what the radii and things are here. I can work out where this hole is, dimension everything up, and that way I've got a good map of the part that I'm actually making. A handy trick with the DRO. I'm working out my coordinates in the absolute coordinate system, but I want to know what the relationship of the centre of this hole is to that point. So what I've done is I've flicked over to incremental. I've found the centre of that hole using the incremental coordinate system, and I've positioned my axes on that incremental 0, 0 point. Now when I change back to the absolute coordinate system, that'll actually tell me where that hole is in relation to that datum point. So just another way to use your DRO. I'm set up ready to start shaping the back and putting the slot in. The slot should go right through that hole. This is just a bit of scrap aluminium I found that I just had to reduce slightly in size, and it was all good. The key thing here is that there's a small hole there. Now that's when I put in there. That's the centre of the part, and so that's going to help me when I flip this over to do the features on the other side. That's going to help me, along with that edge, find the centre of rotation. So that's all lined up. That coincides with the axis of the rotary table. Now it's just a matter of stepping off in the X direction, taking into account the cutter size, and just putting in the reliefs, the slots, all the stuff. So here's one side done. I need to clean up a little bit with the file, but the profile fits. I had a bit of trouble because I've got this bit hanging on still, but that's okay. On this side it's okay. As I said, I need to clean up with the file. I'm now just going to put that chamfer on there. Then I can come along and I can actually shape this with the into its square shape with the, where's the cutout? Cutout goes there, I think, and there's a corner off there. Anyway, we'll do that. But yes, that hole is critical because now I've got a reference between this side and this side, and I can line everything up and get this, roughly in the right spot. Just about running out of daylight today, but this is where I've got to. That slides nicely. The reason it's not going back all the way is that bit there is in the way, and it's not going further forward there because that bit's in the way, which is just the same as this one. So that's all good. The nut screws on there and keeps that tight. I'm hoping that soon I'll be able to weld that piece of flat on there, and that will then give me that extra few degrees. I decided to spare my back and not lift the rotary table up, and instead just did a bit of work with the file. So cleaned up the ends of the holes there, took away that slight little step there. I've put the chamfers on and finished this off, so my reference hole up here is gone. Nervous moment there, trying to think whether there was anything else I needed to do, but that fits on there really nicely. I've shortened this side up so it actually, when it's right down, I've got that parallel, just that's an aesthetics thing rather than anything else. By now some of you might be thinking, well, it's really nice that he's got this super U-Butte flash drill grinder who can do step drills, but I've only got a bench grinder. What the principle is that the drill bit is being fed into the side of the wheel here. Now, for a start, you need to have a decently dressed wheel, not a rounded one like I have, but on a bench grinder. But that's all you're doing. So if you said, how could I make one of those myself? I'd say, right, I'd have a stop that I can run a bolt against, and a piece of probably just a bit of flat of some sort with a bit of angle on top that the drill bit can sit in, and then have a bolt to use as a stop with a lock nut, so that you could feed the drill bit in and get that diameter to the diameter you want. Then it's just a matter of feeding the drill bit into the wheel and until you get to the depth you want, and then, you know, sharpening the tip and the side bits as you want. I'm now just checking my lineup. I've got a bit of ground rod in the chuck here, and I'm just sort of lining that up so that that's parallel with the wheel. Once I've got that, I've put a texture mark down on the scale. Sharpening, I'm told, is basically for the very tip is the same as sharpening a normal drill bit, and the sharpening the step, I'm just going to have to work something like that out. There's the drill that I ground with my fixture, and there's a bit of learning involved in that too, because that is actually a cam, so as well as taking that off, I need to take that off. But it gave me the basis that I could then come along with an angle grinder and sharpen the step. I've managed to produce that, which does exactly what I wanted to do. So happy with that. Thanks for watching. Please spread the word, and see you for the next one.